Hello, welcome all of you to attend the Huawei Routing and Switching, the Elite Training for the Osbf. So my name is Nick Yap as a HCIE from Infosyte. So let's get started on the Osbf training. As we know that Osbf stands for Open Shortest Path First. It's a link state internet gateway protocol that based on the link state algorithm and using the Spf algorithms. And Osbf is mainly used on the enterprise network. So the objective that we're going to cover in this topic, we need to understand the Osbf principle, master the Osbf configuration, the troubleshooting capabilities, and also enhance your Osbf comprehensive capabilities and to strengthen the Osbf exam skill. So in the content that we're going to cover is a Osbf principle, the configuration, troubleshooting, and they have two Osbf cases that we're going to cover, and also on the exam preparation. So this is on the Osbf principle that we're going to cover. We have the Osbf concept, a principle, a features, Osbf convergence, extension features, a management features, a state machine, and also compare between the Osbf and the ISIS. So after the Osbf principle, they're going to cover based on the command, the configuration command in the Osbf, how to troubleshoot the Osbf, the case, and the exam preparation. So let's get started for the Osbf basic. So on the basic Osbf concept, first we need to know Osbf is based on areas to form the topology. The areas is very important in the Osbf. So topology and also the router type that we're going to cover over here. So as you know over here in this diagram, they have an area 0, area 1, area 2, 3, and also area 4. So in total areas that in Osbf they support, it be 2 power of 32. It means that it's equal to a 4.2 billion of the areas that we can configure. So in the areas that we configure, you can based on either using the 0.0.0.0 represent based on the IP address method, or using just a decimal value. So rather than all these areas number, area 0 is always our BB, a backbone areas. So this area 0 you can't change. Always area 0 will be equal to your backbone areas. All the other areas will be called as your non-backbone areas. So let's have a look for the router type that we have in the Osbf. First will be the routers inside the area 0 we call as a BB routers as a backbone routers. So backbone routers, this 4 will be the backbone routers, and also we look at this ABR, the area border routers, communicate between the area 0 and a non-backbone areas. And also we saw this over here, we have an internal routers. Internal routers is within the non-backbone areas we call as a internal routers. So over here is called the internal routers. And any routers, when they connect to the other routing protocol, like in this example, they're connecting to ISIS, and these routers we call as a ASBR, the AS boundary routers. So In this case, which routers can be the ASBR? Every single routers, including the backbone routers, can become the ASBR. So based on which routers perform the import route, you become the ASBR routers. So these are the 4 different type of the router type that we have in the Osbf. And based on the topology, we can either we have a single areas or a multi areas. So we have 4 type of the router type. We have a BB routers, internal, ABR, and also ASBR. So these are the 4 different type of router ID and 2 different topology, single areas or multiple areas. So after we go through all the topology and the router type, let's have a look. In the Osbf basic concept, we need to know also the network type. The network type in the Osbf, they can be divided by 4 network type. We have a broadcast, point-to-point, non-broadcast multi-access, and the point-to-multi-point. These are the 4 different network type that we can perform in Huawei routers. So let's have a look one by one. For the broadcast network type, it's used with the Ethernet or the fiber distributed data interface link layer protocol. And for point-to-point, it's using the PPP or HDLC. Non-broadcast multi-access is based on the frame relay or the X.25 link layer protocol, and point-to-multipoint is always based on the manual configuration. Let me explain it over here. Based on the network type that we have, okay, so we have it's a point-to-point, a broadcast, NBMA, and also point-to-multipoint. So point-to-point, as we know that is a routers using a PPP connections or a HDLC connection. They will know that this is a point-to-point network. Alright, so for broadcast, it means that they're going to connect to the multi-access network. So in this case, are using the switches. They will form using the Ethernet. They form a broadcast network type. So for the NBMA and the point-to-point, point-to-multipoint, you'll be connect using the frame relay or the X.25. But the difference over here between the NBMA and the point-to-multipoint, it means that based on how they are managed to each other. NBMA is a non-broadcast multi-access. It means that they will talk to each other using a full match. And point-to-multipoint, as in HALP and Osbf topology. So these are the 4 different network type that Huawei routers supported. So for the point-to-point, broadcast, and NBMA can detect based on your link protocol. Like point-to-point, that detect based on the PPP and the HDLC, a broadcast based on the Ethernet, and NBMA, they based on the FR or X.25. Except for point-to-multipoint have to define by the user. The user need to define the link type using the point-to-multipoint instead. Alright, let me come back to here. So when we go into the network type, you need to know that within two network type, they were doing the Drbdr election. So which two network type they required a Drbdr election? So only the broadcast and a non-broadcast multi-access, they required a Drbdr election. So why we need to have a Drbdr election within the broadcast network type and the non-broadcast multi-access is because of when you perform the Drbdr election, you reduce the number of the neighbor sections and generate the network LSA. Reduce the number of the generated network LSA. So these are the two requirements why we need to perform a Drbdr election. So let's have a look over here for the Drbdr election. Drbdr elections. So for Drbdr elections, always is depend on your Dr priority. So the default value for the Dr priority, so this is a default value will be 1. So the highest the numbers, the value will be more preferred. The lower the value is less preferred. So they have another one means that when you're using the value of 0, it means you are not in the elections. When you set your value to 0, it means that there have no election going on that routers. So in what type of situation we need to set the Dr priority equal to 0? So let's say when having this topology, we are connected to the frame relay and are using as a hub and the spoke. Hub and spoke. Within the hub and spoke topology, I will set the spoke priority to 0 to not participant in the election to allow the hub to become a Dr. So to allow the Dr to distribute all the LSA information to the spoke and to the spoke. So this is the why we need to set the priority of 0 in our Osbf routers. So for the Dr priority, how they perform the elections. So for the when I come back to here, the Drbdr elections. So how they perform the election? When they perform the elections, always remember for Drbdr election, they always have no preemption. So it means that whoever be the Dr, you all the way you be the Dr. Even those I have a higher value of priority will not take overs. And if let's say when both priority are the same, then they will based on the highest router's ID to do the election. So whoever have a highest router's ID, you become the Dr, and the second highest you become the BDR. Alright, so this one will be more on the DR BDR selection, how they select the DR and how they select the BDR. So next, have a look on the Osbf packet type. So in Osbf, in total we have 5 different type of packet type. So on the packet type, so we have a hello, database descriptions, this requires a DD, LSR, LSU, and the LS acknowledgement. These are the 5 different packets they're going to be exchanged between the two Osbf routers. So let's just have a look for the first hello packet. Let's just have a look on the first hello packet. So in the hello packet, it will be sent periodically to discover and maintain the Osbf neighbor relationship. So how frequent they will send the hello packet, and in what type of situation they are going to send the hello packet. Let me give you an example here. Let's say right now, I have 2 routers using the Ethernet connection connecting to each other, and this is the range of IP address 12.110.24. I have .1, .2, and I will set that this is my router ID 1.1.1.1.32, and this is my router's ID 2.2.2.2.32. So these are the router ID I pre-configured to the Osbf. So before I starting the Osbf, they were under the downstate. When they first started, they were going to the init state, initialized status. Then they were going to send the first packet, requires a hello packet. So within the hello packet, what we need to be concentrate in the hello packet. What they're going to compare inside the hello packet. So inside the hello packet, they're concerned based on the what is your network mask. They need to be matched the network mask, and also which areas you belong to is very important. They must match the area's number, and also they need to know that either do you perform any authentication. The both routers, let's say one end configure authentication, the other end is not configure authentication, they will not able to form the peering. And also the timer. The timer, they need to be sending the packets, need to be matched as well. So in the timer, they divided to 2 different types of timer. One requires a hello, the other one requires a date timer. So for a hello timer, they can either 10 seconds or 30 seconds. It's based on the network type, and the date timers is always 4 times of your hello. So it means that this is 40 second date timer and 120 seconds of your date timer. So they need to be matched between the timer. So in what type of situation we get the 10 seconds and we get the 30 seconds? So in this case, we need to go back to the network type. So for the network type, when you belong to the point-to-point and broadcast, you are using 10 seconds. When it's a point-to-multipoint and MBMA, they're using 30 seconds. Alright, so this will be fixed by default. They're using based on network type to select what is your timer. And The last option for them to perform the peer, they need to be matched, is the stub. The stub areas, the stub flag. So let's say one router define the router method is a stub, the other routers have to define as a stub as well. So these are the 5 information that need to be matched before they can form the neighbor. So this is all the packets, all the information inside the hello packet that need to be matched between the 2 routers. Alright, so this one we call as a hello packet that send periodically. So when using the point-to-point or broadcast, they send every single 10 seconds. When using a point-to-multipoint or MBMA, they send as 30 seconds. So this one you need to remember how frequent they send the hello packets. So later I will show you on the Wireshark to show you that how frequent they're sending the hello packet.
Thanks for watching. Please do not forget to subscribe to our channel.